Put away this marker before I write on it. Okay, so look at the first one. Describe the pattern in the mapping diagram. I'm not asking you to copy because I gave you a copy. What's happening here? What's happening here, Cadence? They're adding 4. Well, that's crazy. Let's try to calibrate it again because it's not. So they're adding 4 every time. Does the rest of you agree with that? Okay. And 3 plus 4 is 7. And 4 plus 4 then is 8. And 5 plus 4 is 9. And 6 plus 4 is 10. Okay, that works. For every input, I get exactly 1 output. There's no other answer. 1 plus 4 is always going to be 5. 6 plus 4 is always going to be, so it's exactly 1 input and 1 output. Nothing weird about that. You agree?
Yep.
Okay. Look at the second one. What's happening on the second one? Joey.
They multiply it by 5.
Times 5. Well, 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. 4 times 5, class? 20. 5 times 5?
25.
25. And 6 times 5?
30.
Is 30. Okay, pardon?
You're increasing by 1 over here and increasing by 5 on the right.
Okay. What I just heard Shelby say that if I go down this side, I could say I'm adding 5 every time. Okay? And if I go down this side, this is plus 1 every time. There's also something, and this is just kind of a freebie out there, that we call it the nth rule. And what that says is on the one on the right, we could call this 5x. You ever seen anything that looks like that? Y equals 5x. If I wrote it that way, what does that remind you of that maybe we were doing before we went on break? Slope. So with that said, could I graph that function?
Mm-hmm.
I sure could. I sure could. What about this one? This one, what would our y equals, if I was to write that equation, what would that one look like? Y equals what? X plus 4. Could you graph that one? Yeah. And would that rule hold true? Well, if x is 1 plus 4, I get 5. If x was 6 plus 4, I got 10. So that would work, wouldn't it? So really, it's some of the same kind of stuff that we've been doing, but we didn't see it quite like this, okay? A mapping diagram. These are called mapping diagrams, okay? Let's talk about a function. First of all, we're talking about relationships here. When we did all that graphing, we talked about direct variation, the relationship between the x and the y, and if it was direct variation, where did the line cross? If it was a direct variation, where did that line cross? 0, okay, 0, 0. All right, so that's a relationship. A relation pairs inputs and outputs. A relation can be represented by ordered pairs. We talked about our x and y's. Ordered pairs or mapping diagram. Same thing. If I look at this mapping diagram here, could I list all the ordered pairs?
Mm-hmm.
Sure I could. Because basically my input is my x, my output is my y. Okay? Just tying it back into that mapping that we were doing, or that slope that we were doing. Okay? Fistify right now. Make sense to you so far? All right, let's see what kind of sense we have. Take a look at this one. Now, list the ordered pairs shown in the mapping diagram. The mapping diagram is nothing more than the picture. A picture is worth 1,000 words. So on your paper, you're going to use your pencil and you are going to write those ordered pairs under the mapping diagram. Austin, I need you to pick up your pencil. It's an interactive class. Takes all of us. If I look at the first one, what's the first ordered pair here on A? What is the first ordered pair? Ty.
1 to 3.
1, 3. Okay. What's the second ordered pair that you see there? G.
2, 6.
2, 6. What else do you see in that mapping diagram? Hang on a minute. Justin.
3 and 9.
3, 9. And finally, what's the last ordered pair? Haley. 4, 12. With that information, could you graph that if you wanted to? Sure you could. Okay. What about B? What's the mapping diagram? What ordered pairs is it giving us? What ordered pairs? Marissa, give me the first one.
0, 0.
0, 0. Okay? I think I put it in. Just a minute. I know I didn't. Yes? Of course I do. I'm so glad you got to call me today. Okay, today we have, let's see, I've got 29. I have 16 regular and 5 alternate. And tomorrow I have 29 regular and 0 alternates. And everybody's here. Yeah, it is. Have a good day. Bye. Yeah, I just like for her to have to call and talk to me. Okay, what about my next set of ordered pairs? What do you see there, Miss Ridley?
2, 1.
2, 1. What else do we see? Bryn? 2, negative 2. And what else do we have on this one? What else do we have here, Natalie? 4, negative 3. What do you notice that is different about A versus B? Anything different that you notice here? Do you notice something different? There are less ordered pairs. 1, 2, 3, 4. No, they're same number of ordered pairs, but there are less variety. You agree with that? And they use the same. What number are they using more than once? The input of 2. Remember when we started this and we talked about the objective? I guess my question is, would this one be classified as a function? If I go back to what it says, you will explain that a function is a rule that assigns to each input exactly one output. One and only one output. So is B a function? No, it is not. It is not. Because my input has 2 outputs. I have 2, 1, and I have 2, negative 2. That is not a function. Okay? And you're going to have to be able to explain. This one is not a function. And this one is a function. Gonna have to know the difference. Okay? And they're so kind that they give us the arrows and they make them different colors. All of this is to help you to see which one is going in the machine, which one is coming out. It's kind of like you take some lady and you take her to the hairdresser and you decide she goes in a brunette and she comes out a blonde. How does that happen? It's a process, okay? So inside the machine, like what I have up here, inside the machine, something's going on to kick out something different. Okay? Same kind of a thing. When would we ever use anything that even remotely would look like this? Other than at the hairdresser. What?
Coding?
Maybe in coding, okay. What about, what if we talked about that hairdresser? What if each one of these outputs was a color? Blonde, brunette, frosted, see what I'm saying? This one person gets all these choices, and maybe she decided to go blonde with curls. Maybe her -2 was curls. She decided we're going to add some curl. She'd really be different when she come out, wouldn't she? But she could only choose one at a time. Only one at a time. What about if it was ice cream? You've got, we could put in sugar cone. We could put in, what do they call is it a cake? Waffle cone, sugar cone, and is it cake cone?
Yeah, I think it's cake.
We'll call it cake cone. You know, the old-fashioned kind.
Those are sugar cones. The waffle cones are the big ones.
Oh, no, those are not sugar. Those old-fashioned kind of cones, they are not
those
sugar
are
cones.
cake cones.
They are really flat, and they don't taste real.
would
I don't know what they
think
call it,
that.
but the waffle cone is usually brown, and they have them at Braum's.
Yeah.
Yeah.
And then they had what was called a sugar cone, and maybe this is something you guys just don't know, because you've just always had waffle cones.
No, I know what sugar cone is. I know what you're talking about. It's like a tan color.
Yeah, and
And it
it's
has
tan.
like the crisscross stuff inside of it.
No,
Like in the.
That
Is
is-
this
no,
yeah.
that's the one I call the cake cone. That's the old-fashioned cone. They're just plain. Eat them by themselves. There's not a lot of flavor.
They have those at Golden Corral.
Oh, yeah, Golden Corral has the old-fashioned cones. Yeah, and the cone, you eat the cone by itself. Does it add flavor to your ice cream?
No.
Nope.
No.
Good though.
No, but the sugar cone was a smaller than the waffle cone, like half the size of the waffle cone. And you can buy them at the grocery store, I think still.
Yeah.
And they're just a brown cone, and it's kind of like the cone that's on drumsticks. That's the sugar cone. Okay, but then the waffle cone. Oh my goodness, they're like the best, right? You can put so much more ice cream in a waffle cone. So see that you got 3 cones, but look, you only get to choose one ice cream. Okay. Well, here's the chocolate, and the chocolate with chunk, but you only get to choose one. There's why we put in the same kind of cone, but the ice cream they get out is different. Okay, it's not a function. All right, look at this one. List the ordered pairs. Everybody has to have the ordered pairs on their paper, and you have to put an F or an NF. F stands for, what would F be?
Function.
Function. NF, not function. Pretty simple. I see your ordered pairs. Let's go, bub. Ordered pairs also. In order for ordered pairs to be ordered pairs, you have to have something there keeping them together. What do we call that? Parentheses. Got to have your parentheses. Then you have to decide function or not function. For both 1 and 2. Do 1 and 2. Because you know what? Does this seem hard to you?
No.
No.
So what do you think about your homework today? Is it going to be hard?
No.
No.
There's gonna be another thing that's what Sid makes us do something.
Oh, you think there'll be a twist?
Yeah.
Sometimes.
Unless you're really nice and just don't give us homework.
Okay, I
My
want to
sleep
know.
schedule would like that.
Chase, tell me the ordered pairs on number 1. 0, 12. What else? 2, 10. Keep going. And 6, 6. Michael, is number 1 a function? Oh, he's gone. Annie, number 1, function or not function? Function. Why? How do you know? You're right. How do you know? There is exactly one output for every input. One and only one. Good job. Okay, right, I need ordered pairs for number 2. Order, Dakota, you think you're just gonna sit there and not talk to me today? Ordered pairs, please.
1 and negative 1. 1 and negative 2. 2 negative 3. 2 negative 4.
Thank you, sir. Okay. Hi. Tell me, Lily, is it a function or not a function? Not function. Awesome. Okay. I like it. Haley, question, comment?
No, I'll tell you why.
Okay, tell me why.
Because for every input, there's 2 outputs.
Yeah, each one of these inputs have more than one output. Not a function. Okay? This is simple. All you gotta do, is it a function or not a function? Miss Molly, look at A for me and tell me, is it a function or not a function? It is not a function. Why not? Do what? Can the output be used more than once?
No. It never says.
Because it said there just
Yeah,
has to
just-
be one input for one output. It never said that there could be 2 different.
Okay, Molly, I tricked you. Sorry. Honestly, this one is a function because if I was to list the ordered pairs, and this is your check, this is how you know if you're right. My input can only be used once. For every input, there is exactly one output. This one, A, is a function. Every input has exactly one output. Okay? The rule doesn't apply to the outputs. Now, notice they did shorthand, math shorthand here. They could have listed that 10 twice, couldn't they? And it wouldn't have hurt anything, but they didn't want to. So they said, in my mapping diagram, I'm only going to list the 10 once and draw a couple of arrows. Perfectly legal. Okay? Perfectly legal. Now the question is B a function or not a function? Ethan, I haven't heard from you, I don't think. Not a function. How do you know that, Ethan? Tell me what told you it is not a function.
I don't know.
Okay, let's go back to our objective. You will explain that a function is a rule that assigns to each input exactly one output. Look at your inputs. Do any of the inputs have more than one output?
Yes, 0 does.
Exactly. And this is why it is not a function. Because 0 is 0, 5, and the ordered pair 0, 6. It is not a function. Bryn, are you okay with that? I saw that little scrunch there. I don't know about this. Okay? Any questions? Consider the mapping diagram. Determine whether the relation is a function. Give me thumbs up if you think it's function, thumbs down if you think it is not. Keep it right here if you want so nobody else is looking around, and I can assess that myself. From what I can see, this is what I'm seeing, that it is a function. Who's going to tell me why? How do you know it, other than the person next to you did it? How do you know it? Grace, how do you know it? Yep, there is only one output for every input. Only one. Good job. Describe the pattern of inputs and outputs. Now it wants to know what's happening. What's happening inside that function table? You put in a 1, so you're going to go up here, and here's my function machine. And I'm going to, whoops, wrong pen. And I'm going to dump a 1 in, and it's going to come out as a 15. What happened inside that machine to turn it into 15? What happened to it? What happened to it, Madison? You're saying 1 times 15. Okay? So I've got the ordered pair 115. Do you agree?
Mm-hmm.
Well, is that going to happen? What if I dump a 2 in there? What's going to be my output? 30. Does it work?
Mm-hmm.
So my pattern then is 15x, isn't it? Because 15 times the input every time gives me, we're going to call it RY, just because we're used to that. Okay? That 15 also represents what to you?
Slope.
Slope. It's the rate of change. It's what's happening inside the box that changes. Okay? Good job. Ladies and gentlemen, we're moving right on along. You guys are doing great. I am so glad we had spring break. You guys are on fire today. You just don't even know it yet. All right. Determine whether it's a function. Number 3, is it a function? Thumbs up, thumbs down. Thumbs up or thumbs down. All right, here's what I'm seeing, and I can't draw a thumb, so I'm going to have to say non-function. Now, Tyler, why?
Because there's 2 inputs for 1 output.
No, there are 2 outputs for 1 input. Okay? So negative 1/2 kicks out a 2. Negative 1/2 also kicks out a 4. Not a function. What about number 4? Thumbs up, thumbs down. Number 4, is it a function or not? Austin, is it a function or not? Talk to me, bud. What? Number 4 is a function. I totally agree with him. Totally. How do I know it's a function? How do I know it's a function, Ethan? 1 to 1. There is only 1 output for every single input. Let me see here. Describe the pattern of inputs and outputs in the mapping diagram on number 4. Okay, I'm going to put in a 2. What happens to the 2 that it's kicking out as a 6? It comes out as a 6. What happened to it? 2 plus 4? Well, that would be one way, but is it going to hold true if I kick a 4 in there? If I shove a 4 in and I get a 3, something's wrong there. What's happening?
It's gonna be multiple step, wouldn't it? It's not just gonna be one addition,
Outputs are going down
subtraction.
by 2, but your inputs are going up by 2.
Okay. My outputs are going down by, what'd you say? 3? Six minus 3 is 3. 3 minus 3 is 0. 0 minus 3 is negative 3. Okay, I agree with that. And the inputs are going in and increasing by 2. Okay? I can't write a pretty little statement there. You agree? I can see the pattern. I know what's happening. But I can't make it pretty, can I? Okay? So you're not always going to be able to make it pretty. That doesn't make a difference as to whether it's a function or not, Zoe. What determines if it's a function? What's the determining factor, whether it's a function or it's not a function, Joey?
The input has exactly 1 output.
The input has exactly 1 output. Okay. I want you on a piece of paper, make sure your name is on it. I want you to describe the pattern in this table. You're gonna make a mapping diagram, that's what we've been dealing with, and list the outputs and list the inputs in it. What's the pattern here? You gotta put it on paper. That's gonna get handed in to me. Then on the next slide, just so you know where it's at, is your assignment. But I want this before you do the assignment. That way I can see if you're understanding what we're doing. And you've got another 5, 10, 15 minutes to work on your assignment once you get that done. Okay, so that needs to be on a separate sheet of paper because you're going to turn it in. That's what I thought. Oops, turn the projector.